This video is part 4 of a unit on vibrations and waves. Specifically, this particular video will cover wave interference. Wave interference is a behavior or pattern that occurs when waves arrive at the same place at the same time. Waves can interfere with each other, and that's the big idea for this video. Wave interference is only one of several different behaviors or patterns that all waves exhibit. Other patterns include reflection, refraction, and diffraction. We will take a look at those behaviors in later units on sound and light. Waves are a phenomenon that occur in materials or in the vacuum, but when they're in materials, what they actually are disturbances or energy moving from one place to another. So while materials can't actually occupy the same space at the same time, energy certainly can. So waves can overlap, and that overlapping is what we call interference. When waves overlap, they can make interference patterns. These regular appearances of light and dark, for example on the screen here, are the result of two waves that are overlapping at the same places and times. If you think about transverse waves and you think that they have these crests and troughs, if two crests overlap at the same time, the waves add together and you get a larger crest, a higher wave. You also get lower lows. That's called constructive interference. So in constructive interference, the waves overlap in such a way that you get an increased amplitude or height of the wave. It's also known as wave reinforcement. Here's a depiction of two waves, and if you bring them together into the same place at the same time, both the crests will overlap and the troughs will overlap. These waves are said to be in phase with each other. The result of an overlap will be a taller wave, a reinforced wave. It has twice as much energy as the individual waves. So constructive interference results in waves of higher energy or taller amplitude. On the other hand, if a crest and a trough of two different waves overlap, they can destroy each other. This is called destructive interference. The high part of one wave fills in the low part of another, resulting in a cancellation of the waves. Here's a depiction of two waves that are said to be out of phase. As one is rising, the other is falling. So a crest will overlap with a trough if we bring these two waves together. And what you'll get is no wave at all. The wave can completely disappear while the waves are out of phase with each other. This is called destructive interference. So I used these terms earlier, but they're good terms to know. If we use the terms out of phase, that means the waves are arriving at the same place and time, but the one will have a crest while the other is having a trough at that particular place you're looking at. If the two waves are of equal amplitude and of equal wavelength, then when they are completely out of phase, you can actually totally cancel the wave and get a zero amplitude. On the other hand, if waves are in phase, the crests are arriving at the same place and time, and you can get higher crests and lower troughs. You get a wave of greater energy. Those waves are in phase. Wave interference can be seen in water waves, and especially if we were at school right now, we could use a ripple tank, a special constructed device that has a very shallow pan of water, and it has a light shining through it, and then it will have some sort of wave maker. In the particular diagram here, it has a paddle that will oscillate back and forth, pushing the water towards either end. And you can see projected on the screen below the pattern of the wave. What we see here is a simulation of a ripple tank with the paddle in place at the top of the screen. The light and dark patterns are actually a result of the thickness of the water. Where the water is very shallow, you see a lighter green color, and where the water is very thick or tall, that's where you see a black shadowy region. So this is simply a simulation of what you would see if you were looking at the pattern produced by a board shaking back and forth in a shallow pond of water. Of more interest to us is what happens when you replace the paddle in the ripple tank with a single point source of a wave, something that's known as a dipper. So this is just a little piece of metal that will bob up and down, producing these ripples in the water. Now watch what happens when we show a simulation of the dipper at the top of the screen. This is with a single source, a single dipper. What's really interesting is to see what happens when you have two waves at the same place at the same time that are caused by two dippers. So here's the pattern with two dippers. You see them at the bottom of the screen this time, and you'll notice that they are definitely making a weird looking pattern. At the middle top of the screen, you see waves from the single top dipper, but on either the left or the right side of the screen, you see where the waves are overlapping. Where they overlap and completely out of phase, you see fuzzy areas. So here's a still photo of a ripple tank with 2 point sources, and you can definitely see the interference pattern. Those fuzzy areas where complete destructive interference is occurring, and then the darker and lighter in between is where constructive interference is occurring. One thing I need to add is, though we have constructive and destructive interference, those waves actually are separate waves caused by separate sources and will continue moving. So even though it appears like the wave is destroyed, that only occurs at certain points. The wave itself actually moves right through that point, and that energy keeps on going. Interference patterns are not confined just to water waves. You can see them also in light waves, or you can hear them in sound waves. What we see on the screen right now are two transparent plastic sheets that have concentric circles printed on them. And when you overlap them slightly out of phase, you can see the interference patterns. These are called moire patterns. It's actually a phenomenon that was named for a particular silk fabric, where you can see this phenomenon occurring in the silk. So as I said, interference is a characteristic of all waves. We will see it when we look at sound waves in a later unit and light waves in a unit after that. Interference occurs in all types of waves, and you can have constructive interference where the two waves overlap in phase, or destructive interference where they are out of phase. Now, in this particular video, we're showing idealized examples where the two waves have the same wavelength and frequencies and amplitudes. But in real life, waves come at you from all kinds of different sources and different directions, and with all sorts of different frequencies and amplitudes. And so interference can be quite a complicated phenomenon. For an even better understanding of wave interference, please look at Hewitt-Druitt number 86. You can either just Google that, Hewitt-Druitt 86, or here is the YouTube address. So there are other wave behaviors besides interference that we will be looking at when we get to sound and light in later units. We are looking at interference right now just because it leads to some interesting effects that you can see in your world around you. So that includes standing waves, which is the topic of the next presentation.